Hello, and welcome to the Kane Sterling BIM presentation. Today we're going to take an in-depth look at the Kane security screens and Kane Detention products for Revit Architecture. Kane Sterling has teamed up with the Revit content developers at Revitus to create a comprehensive Revit content library full of information-rich, fully parametric families that are very functional and user-friendly. Let's jump right in. The Kane security screens Revit families have been strategically developed with the Revit end user in mind. Each security screen model has been created to offer an authentic representation of its real-life counterpart. All of the Kane Sterling Revit content has been developed following the guidelines of the Autodesk Revit Model Content Style Guide. This helps to ensure that this content is of high quality and performs well in the Revit project environment. All Kane security screens are classified under the Specialty Equipment Revit category and have been developed as wall-based families. This requires a wall to be placed in the Revit project prior to inserting a screen component. Each family file includes a wealth of information, all of which has been deliberately coordinated with the actual product specifications. These families are fully parametric and will ensure superior functionality when they are loaded into the Revit project environment. Let's take a closer look at the parameters included here in our first example, the surface-mounted Level 5 operable steel narrowline. At the very top of the Family Types dialog box, you will find the family type name. For all Kane security screen family types, the name is simply denoted by the overall width by height of the unit and should always be expressed in inches for consistency. Every Kane security screens family file will have at least one predefined type. This gives the architect a great starting point from which to begin modifying the parameter values to meet the needs of the specific project. Additional types can be created easily in either the Revit project environment or here in the Family Editor. Here you would simply click the New button, fill in the new size for the type name, click OK, and adjust all parameter values as necessary. You can have an unlimited number of family types included within each family file, and each type will typically represent a different size. As we investigate the parameters included in this example, you may notice that several parameter values are grayed out. This prevents the parameter value from being modified manually and may have been done so for a number of reasons. For example, notice that the first grouping of parameters is labeled as constraints. These types of parameters typically don't want to allow for modifications because they are designed to satisfy the rules of the components. As the specifications and actual product limitations will reveal, a center mullion may be required if the width of the unit exceeds 50 inches. Instead of requiring the architect to be fully knowledgeable about every limitation of each product, we've simply built this functionality right into the Revit content. Often, these rule limitations will be expressed as conditional statements in the form of formulas. When a parameter value is changed, and the rule is either satisfied or broken, Revit will automatically adjust the model elements to remain accurate to the product limitations. Sometimes these formulas can get quite complex, but this will ensure that the models function just like the actual physical products they represent. These locked out parameters should not be tampered with. To finish out the topic of locking out parameters, other reasons for doing so include the following. If only one option exists, such as a material that is always finished with a black powder coat finish, or if the specifications alert the architect of product limitations as a text note, we have included that information in the Revit content as well, simply to help educate the architect about the product allowances and limitations. When multiple options are available for one parameter, the Revit user may be presented with a simple drop-down selection box. Just choose the option you want to specify, and Revit can then automatically schedule that option for you. Shared parameters have been defined accordingly. These selectable lists have been pre-populated with all of the standard options based on the product specifications. When multiple options exist for the graphics of a material, however, an ellipsis button will launch the materials dialog box and will allow for any selection in the materials list. All of the standard finish options have been included within each family file. This way, when any Kane Sterling Revit component is loaded into the Revit project environment, all of the available materials and finishes for that product will be loaded as well, giving the architect easy access to choose the finishes required for the project. Each material has been custom developed to include visual properties for color and shaded views, and surface and cut patterns. Render appearances have been applied to ensure that the same high-quality level of detail will be evident when the architect generates his photorealistic renderings of the Revit BIM model. It should be pointed out now that two separate sets of materials parameters have been included in each family file. One will control the way Revit graphically displays the material in the model. The other will control how Revit schedules the material. Revit currently does not allow for these two parameters to be linked, so it will be up to the architect to verify that they are coordinated in his building information model. Additional functionality has been added to some of the family files to allow a simple toggle checkbox to turn on or off additional accessories. In the SNR50 example, there is an option to show an aesthetic horizontal brace. This conveniently enhances the design options to allow the architect more flexibility in matching a window mullion pattern. The height of the horizontal brace can then be controlled independently using the parameters found under the dimensions grouping. Speaking of the dimensions parameters, we have again made the architect's job as easy as possible. For all surface-mounted security screens, we have included parameters for daylight opening width and daylight opening height. So even if the architect doesn't know how far the frame is required to overlap the opening, they can simply enter the actual window size using the daylight opening parameters, and Revit will calculate the overall unit width and height for you. Let me point out that the dimensional parameters for the reveal mount families are different. As you can see, the daylight opening parameters are omitted, but a wall inset parameter has been included. This will allow the architect to control how far back into the wall the security screen is recessed. Other than these few slight parameter differences, the surface mount families and the reveal mount families are essentially identical. For all security level 5 and higher screens, additional data parameters have been included to emphasize that the products have passed the Housing and Urban Development SAG, Impact, and Forced Entry tests. The identity data group of parameters helps complete each family file. You will find a lot of useful information here, starting with a website homepage link. Simply click the ellipsis to the right of the URL, and the default web browser will automatically launch and take the architect straight to the new Kane Sterling website. To go one step further, we have included a product page URL, which will take the architect directly to the specific web page to get more information about the product they are working with in the Revit model. Additional information found in the identity data parameters includes security level, model number, manufacturer, description, and we have even given the Revit users direct access to the Revit Content Creator website in case they want to learn more information about Revitus, or if they want to provide feedback about these files. Also included is a CSI specification section reference, as well as the version of the Revit file. This will help troubleshoot any problems that could potentially arise by ensuring that the architect is working with the most current file. All Kane Sterling Revit content has been developed with the 2011 version of Autodesk Revit Architecture. Since Autodesk releases a new version of Revit every April, it is our intent to upgrade these files at that time each year, to always stay just one release behind the most current version. Before we jump over to the Revit project environment, let's take a look at some of the Kane Detention Revit families. Just like the security screens, the Kane Detention products are also classified under the specialty equipment category. However, there are some key differences that should be pointed out. All of the Kane Detention products can be placed freely anywhere in the model without requiring a wall or any other object to act as a host, with just two exceptions. The Defender Interview screen is wall-based, similar to the other Kane security screens. And we have created a Detention Ceiling Light fixture, which is a face-based family that will be hosted by the Detention Ceiling object. But all other objects can be placed anywhere in the model. Let's open the Level 9 Vantage Wall Barrier and explore the data that's been included. When we open the Family Types dialog box, we'll first point out that the type name format is different than the security screens. Instead of denoting the size of the product, the Vantage Wall Barrier family types explain the mounting type and the material of the main frame. If we drop down the list of predefined types, you can see that all of the standard types have already been created and the parameter values have been populated accordingly. This again will help make the architect's job even easier. The width and height parameters of the Kane Detention Vantage wall barrier are instance-based. This means that you can place two identical reveal-mounted galvannealed vantage wall barriers in your project, and one can be 10 feet long and 10 feet high, and the other can be 11 foot 4 inches long and 8 foot 6 inches high, or any other size, without having to create duplicate types. In the Family Types dialog box in the Family Editor, the instance-based parameters are easily identified by the default suffix beside the parameter name. A parameter is defined as instance-based or type-based when the parameter is created, and can be modified after the fact by using the Modify button. Note that when the object is loaded into the Revit project environment, all instance-based parameters show up right in the Properties window when the object is selected, and type-based parameters can only be accessed by clicking the Edit Type button, which calls up the Type Properties dialog box. As we investigate the other Vantage Wall parameters, the Revit user has the option to turn on one or two optional horizontal braces. And for the added convenience of maximizing the design options, these are instance-based as well, as are the heights at which these braces are mounted. All standard materials and finishes are included in the file, and some product limitation notes will help educate the architect about the product. Notice all of the grayed out parameters and formulas in the other grouping of parameters. These define the functionality and rules of the geometry and will actually allow the proper number of panels to be included for any length vantage wall required, which could be one panel or several. While we're discussing the topic of multiple panel units, let's go back to the security screens briefly. You should understand that the functionality of the security screens will only accommodate one wide and two wide units. Adding the functionality of allowing multiple wide units would have increased file size excessively and degraded performance, and would have ultimately led architects to become frustrated with using these Revit files. Rest assured we have created a solution for this scenario. Additional frame mullion families have been created to separate each panel required in the multi-panel screen unit. If the architect requires a security screen that is 300 inches wide or 25 feet, made up of 6 panels side by side, he can insert 6 individual 50-inch units and 5 mullion objects, or 3 100-inch units and 2 mullion objects. But again, the Kane Detention wall objects and the security ceiling objects will automatically accommodate any number of panels required based on the size specified by the Revit user. To finish out our exploration of the Vantage Wall barrier, the identity data parameters will offer the same basic information as the security screens, making for a very complete and useful Revit family. Let's just take a quick look at the data included in a door object, and then we'll pull everything together in the Revit project environment to show you how it all really works. We have developed both the pre-hung and sliding Vantage Wall doors, and each can be had with or without a transom panel. All subtypes for galvannealed, stainless steel, and steel construction have been predefined in each file. Primary dimensions for doors are type-based, just as the architect should expect them to be. Under construction, we have included all standard options for the Revit user to define the middle rail and bottom rail types with a simple drop-down selection list. The graphics of the door object will update as soon as the changes are applied. For the pre-hung doors, we have included an option for the planned swing angle, which is instance-based. This will allow the architect to show the existing doors at a 45-degree angle and new doors at a 90-degree angle, or any other angle between 0 and 180 degrees. For the sliding door, we've included the option to show the door in the open or closed position. The rest of the parameters should look familiar by now and complete these families. Now that you have seen how robust this content is, let's take a look at it in the Revit project environment so you can see how easy it is to work with and how it all actually works. The most typical process for loading Revit families into the project file is to use the Component tool, found on the Home tab of the ribbon. Once the command is executed, a contextual Modify tab will appear and will allow you to select Load Family. When you choose Load Family, a dialog box will open and display the default folder structure for the architect's Revit content library. All Kane Sterling Revit content is classified as specialty equipment, and this is where the architect should have downloaded the Kane Security Screens files to. Select the product you wish to load and choose Open. The Revit component will be loaded into the project and will be ready to be placed in the model. Since the security screens are wall-based families, you will notice that the component cannot be inserted until you hover on a wall to host it. The best practice is to place the object freely, and then use the Align command to reposition it more accurately. Once in the Align command, pick the reference of where you want to move your object to. Next, select the reference of the object you wish to move. Immediately after you align an object, a padlock icon will appear, giving you the option to lock or constrain the relationship between the two objects. Once constrained, moving either object will actually affect both objects to maintain the constrained relationship. Note that a Revit model can become over-constrained quite easily if the Revit user gets carried away with locking padlocks. Best practice is not to lock these two objects together. To remove the constraint, select either object and click the padlock icon again to unlock it. Now that we have the default SNR5O component loaded and placed in our project model, we can investigate it further and modify it to meet the design of our project. Let's switch over to a 3D view to get a good idea of how the security screen looks currently. We can see from this view that the screen is much too large for our project needs, so we will want to reduce the width and height to match our window. Also, notice that the window style is a single panel unit with no dissecting mullions. To match the window, we will want to turn off the horizontal braces and eliminate the vertical mullion. Based on the rules and functionality of the security screen family, you will see that much of this will happen automatically when we adjust the size. The first thing we have to do is determine the size of the window to match. Simply select the window and look at the information in the Properties dialog. It tells us that the window is 24 inches by 32 inches, and the sill height is at 5 foot 4 inches above level 1. Now we are ready to modify our security screen. Simply select the security screen object in any view, and on the Properties dialog, choose Edit Type. The Type Properties dialog box appears. The first thing to do is rename the type to denote the new size we need. For our example, I'll enter 28 inches by 36 inches and click OK. As we browse down the list of parameters, uncheck the box for Show Aesthetic Horizontal Brace. Continue down to Dimensions and adjust the width and height, or the daylight opening width and daylight opening height to match the window dimensions. These are the only changes required at this time. Click OK and Revit will apply the changes to our revised security screen family. The first thing you'll probably notice is that the screen is much too low on our wall. Browse over to the Properties window again and we can see that the sill height is too low. Adjust the instance-based parameter value up to 5 foot 2 inches and the screen is now located perfectly on the window. The other point to make note of is that we only turned off one aesthetic horizontal brace, but now we see that both braces and the vertical mullion are gone. This comes back to the rules that are built into the back end of the Revit families. We can still add the aesthetic horizontal brace back in and use the dimensional parameter to control its vertical placement. Next, we're going to take a look at detail level to see how visibility settings have been incorporated into each family file to complement the scale of the view. I am going to load the Level 7 Steel Defender into the project. And just to change things up a bit, I'll load the reveal mount instead of the surface mount. We'll go ahead and place one anywhere, then modify it to match the window size again, except I will duplicate the type this time to show you that. Simply click the Duplicate button, enter the type name, click OK, then modify the width and height settings to match the window size. While this dialog box is open, I'll point out that the parameters for this family are different than the narrow line. Horizontal braces are not required nor allowed for this product, so the parameters and functionality for that has been omitted here. Lock release options are specific to this product and again will schedule accordingly. So while the exact parameters and options may vary from product to product, the organization and concept of the families is consistent and very complete. Again, I will align the screen to the window and raise it to the proper installation height. Okay, back to the point of detail level. On any typical project, an architect will create multiple views of varying scales. High-quality Revit content take these considerations into account by strategically planning and utilizing visibility settings. Simply put, less detail shows up in smaller scale views and more detail shows up in larger scale views. The primary reason for this process is to ensure that these families remain legible and graphically acceptable on all printed output throughout the bid document sets. Level of detail works the same for section and detail views as well, and the concept is the same when we look at elevation views too. An overall elevation view shows a fairly generic, simplified version of the component. Enlarged, medium detail views enhance the graphics and include elevation swing lines, if applicable. Now let's look at a legend view to see the fine detail level. Legend views are typically used by architects to show their door type elevations and window type elevations, among other things. The Kane security screens Revit families now make it just as easy to create a security screen types legend view. Just go to the View tab on the ribbon, and under the Create collection of tools, choose Legend. Give your legend view a name, set the view scale, and click OK. Set the detail level to Fine. Then go to the Annotate tab and fly out the Component tool, and select Legend Component. On the Options bar, expand the Type Selector list, scroll down to Specialty Equipment, and choose a security screen to insert. Choose the type of view to show for the component and place it anywhere in the view. Continue inserting additional types as required. These legend components are not actual physical objects in the model, so if you query the quantity of security screen objects in the building information model, these legend components will not affect the count. Notice that brand recognition becomes readily identifiable for the fine detail level views. We've taken great care to include the Kane Screens and Kane Detention Company logos to allow for this brand recognition right on the bid documents, without overdoing it and without annoyingly muddying up the architect's drawings. The architect can have and use the Revit content for free, and the only stipulation is that they specify Kane Sterling as basis of design. That's not too much to ask, and it's a good deal for both of you. To get back on track with our legend view, the architect would continue developing the view by adding dimensions, text notes, and detail lines. Here is an example of a completed security screen types legend view. Okay, we have finally come to the last main topic of working with the Kane Sterling Revit content in the project environment: schedules. Revit schedules are as easy to create and manage as any other view, and in theory, these schedule views are just another way of looking at the same building information model, but in list form. Revit is actually a database application. All of the objects placed in the model make up the database, and Revit schedules simply show you lists of all the objects in the database. The parameters that have been included in the Kane Sterling Revit families have been deliberately planned with schedules in mind. To best illustrate what I mean, let's create a complex security screen schedule from scratch. We will again use the View tab to create our new view. Pick the Schedules button and an expanded list of options will fly out. Here you could choose to set up material takeoffs, sheet lists, and more, but we'll choose Schedules Quantities. In the New Schedule dialog box, you'll see that schedules can be created for virtually any Revit category. Since the Kane Sterling Revit families are specialty equipment, we will scroll down the alphabetized list to find that category. Next, we will give the schedule an appropriate name and click OK to continue setting up our schedule. The Schedule Properties dialog box is where we control all aspects of the schedule. We will start by selecting the fields, or parameters, that we want to appear in the schedule. The first field we want to include is Type Mark. The type mark is what the tag will read that will be added later to our floor plan. Let's add additional fields for manufacturer, model number, width, height, egress and lock option, lock release option for face and stop side, primary finish, infill finish, infill type, mainframe and infill finish, and count to create a complete and robust schedule. On the Filter tab, choose to filter by manufacturer and make it equals Kane Security Screens. What this filter will do is remove all other types of specialty equipment from this schedule that aren't from the manufacturer Kane Security Screens. There are many different objects in Revit that are classified as specialty equipment. Some of these could include instructional boards, fire extinguishers, toilet room specialties, and many other items that we don't want to include in our security screen schedule. For sorting and grouping, just sort by type mark in ascending order. We'll accept the default values for formatting and appearance for now. Click OK, and the schedule is generated and populated with all of the security screen objects in the model. The schedule view has been added to the project browser and is ready to be placed on a sheet. To do so, just open the sheet file you want to add the schedule to. Then drag the schedule view from the project browser and drop it on the sheet in the drawing area. Click to place the schedule anywhere on the sheet, and use the blue triangular grips to stretch each field out as desired. As we investigate the schedule, notice that type mark is blank. This is because we have not yet assigned a parameter value to our family types in this Revit project. Now is the perfect time to do that, and of course it is very easy. As is typical with most tasks in Revit, any process can be completed in a number of different ways to arrive at the same end result. Assigning a type mark is no exception. I'll quickly show you 4 different ways to do the same thing. First, find any model view that shows a security screen. Select the screen object and on the Properties dialog, choose Edit Type. Scroll all the way down to the Identity Data Parameters and find Type Mark. Simply enter your designation here and click OK. Browse back to your schedule or sheet view to see that the change has been coordinated immediately and automatically. The second option is to locate the family type on the project browser. Simply double-click the type name and you'll see the same Type Properties dialog box as before. The third option is to change the value by using a tag. Go to a medium or fine detail level plan view and tag the object using the Tag by Category tool from the Annotate tab. Adjust your preferences on the options bar and place your tag. Again, notice that the value is blank since I cleared the designation in the second example. Now just select the tag, click on the question mark, and enter your value. A Revit warning will alert you that this may affect many elements. This is good since you want all identical screens to be tagged and scheduled the same. Click Yes to continue. Return to the schedule view again to see the results and prepare for the fourth option. Here is the real beauty about schedules. Schedule fields can be modified directly in the schedule, and all changes will be updated throughout the entire model. I'll enter SS2 for type mark for one of the screens. Again, Revit will alert that this change will be applied to all elements of this type. Click OK and continue filling out the type mark values. To reiterate the coordination aspect, I'll change SS1 to SS4, and I'll change the width to 4 foot 8 inches. And let's go have another look at the plan view. You will see that the tag is updated and the object is wider. Back in the schedule view, notice that every parameter that has multiple options can be modified right in the schedule. Finally, let's have a look at the count field. Currently, there is only one instance of each of the screen types. We are now going to copy more instances in the model to show you one last feature of schedules. Over in our default 3D view, I'm going to select a screen and utilize the Array tool to make several copies at once. On the options bar, uncheck Group and Associate, change Number, check Constrain, then click anywhere in the drawing area and drag in the direction you want to copy. Type in 8 foot 8 inches and push Enter. 11 copies have been made. Once again, go back to the schedule view. You see that each instance is itemized separately on the schedule. This makes for an excessively long schedule and doesn't make much sense. But there is an easy fix. On the Properties dialog, beside Sorting and Grouping, click Edit to call up the Schedule Properties dialog box again. On the Sorting and Grouping tab, uncheck Itemize Every Instance and click OK. The schedule list has now been consolidated to show each different type only, and the total quantity of each type in the model is being reported. If you wish not to print that piece of information on your sheet, which it currently would, go to the Formatting properties, select the Count field, and check Hidden Field. The field is actually still part of the schedule, but the visibility is now turned off, preventing it from displaying or printing. Best practice would be to duplicate the schedule view, rename it and include a descriptor like Working View or Reference Only, and display all fields in this view to work with, while printing only the fields you wish to display in your other schedule view. With all of the information I've covered thus far, you should now have a good understanding of the Kane Sterling Revit content. I'll take just a few more minutes to show you how easy it is to work with the Kane Detention products. I'm not going to explain every little step in detail as I've done so far, but instead I'll just show you what an architect will do to create a typical cell and then propagate those objects to quickly design complete cell blocks simply and efficiently. Working with the Kane Detention products in Revit is really quite simple. Let me show you what I mean. Our example project is a detention facility with 3 cell blocks. I have an enlarged cell block area plan. I'm going to develop one typical cell and then copy that around the project. To bring in the Kane Detention products, simply use the Component tool. I'm going to bring in a Vantage partition barrier. Click Place on Work Plane, put it at the first floor. I'm going to free place 2 of them anywhere. I'm going to continue inserting other components, including a Vantage wall door, pre-hung. Again, place it anywhere. Use the control grips to change the hinge and swing as desired. I'm going to place a temporary dimension, and I'm going to click the equality constraint. Then I'm going to uncheck it. This centers the door in the cell. I'm going to type in AL to get into the align command and align from the outside face of the wall to the outside of the door. Continue the align command by picking the door jamb and the vantage partition. Align the partition to the wall. Notice that the number of panels updates automatically as required. Continue aligning and repeat for the other side. I'm going to open my quarter scale typical cell plan to place a couple more components, including a toilet and a sink. Place them anywhere, and I'll also insert a bunk bed. Spacebar twice to rotate it around, a line tool to place it against the wall, dimension to locate the fixtures, just like that, my typical cell is pretty well complete. Now all I have to do is select all of the objects that I want to be in my typical cell and click Create Group. I'll call it Typical Cell Layout. Click OK. Back in my cell block plan, I can then take that group and mirror it to the other side of the wall and then array it. I'll choose 12 times. Make sure Group and Associate is unchecked. I'll go to the second, pick anywhere, type in 8 foot 8 inches. And I now have 12 additional copies of that group. I can then select any one of those groups, right click, select all instances in entire project or visible in view, and I'll mirror draw based on the midpoint of the wall and copy all of those up to the other side. Back in my overall plan, I can again take any one of those, select all instances in entire project, mirror draw from my midpoint, and copy them over to the other side for cell block 2. I can then draw a temporary detail line. Then I'll use filter by selecting the entire cell block, choosing filter, check none, and I only want to select the model groups, which are my typical cell layouts. Choose rotate, copy, change my point of axis of rotation, click anywhere, 90 degrees, and all 3 cell blocks are now complete. Delete my temporary line, and there's one more object we have not yet added, the ceiling. I'll open up typical reflected ceiling plan. Again, I'll place a component. I'll choose Detention Ceiling, and I'll just pick the acoustic panel with top plate. Spacebar to rotate if you need. A line tool to resize it. Notice that the light always stays in the center, and the number of panels updates automatically based on the overall size of the ceiling object. Now all I have to do is add that ceiling object into my group. Select the group, edit it, click Add, choose the ceiling, click Finish. The ceiling now shows up in every single cell. One thing we didn't look at when we placed our ceiling was the height. I'll switch over to a 3D view. I'm going to hide the roofs category so we can peek inside the building. And we can see that our ceiling is too low. It's cutting through the window. Again, simple fix, select any group, edit the group, select the ceiling, adjust the height. Let's just pick 9 feet. Click Finish, and all the other model groups will be updated and the ceilings will be raised. If we cut a building section down one of the corridors, we can get a good look at the cell fronts. If your design requires a different type of door, as far as the middle rail and bottom rail are concerned, edit the group, select the door, edit the type, Change your middle rail and bottom rail types. Click OK, and all of them will update. Finish editing the group. Again, from the reflected ceiling plan, there may be a call out for a typical south reflected ceiling plan. This would generally be at 1/4 inch per foot, and the detail level will be set to fine. Thus, the Kane Detention logo shows up for the brand recognition. One additional thing to point out about the ceilings. We've included a simple toggle to show the light fixture or turn it off. We've also included a separate Revit family file of just the light fixture so that you can place it anywhere within your ceiling. You can now see how easy it is to work with the Kane Screens products and the Kane Detention products in Revit. To download these files and to learn more information about the Kane Security Screens and Kane Detention products, go to the Kane Sterling website at www.kanesterling.com.